And so next up, we have Integrated Science and Flight Operations by Kring et al.
Okay, so I want to start with, let's see if I can close this.
Hey, Dave, I want to make them full screen. We're still seeing your PDF viewer. I think you can click Control L.
Oh, okay, let me try that. Because my normal button that I do, what? Nope, Control L says leave meeting.
They're definitely viewable. Like we can definitely read them, so you can probably progress like this.
Wait, what is the thing up here?
If you'd go to full screen mode down that list. Yep.
I think he is in full screen. His is in the older format.
Okay. Well, we can definitely read it like this, David. So.
Okay. I'm sorry for the delay.
Ricky, if you can start his time over. Just sorry. Yeah, start your time over. There you go.
Okay. Yeah, I can't see the timer, by the way. So give me a 1 minute heads up, if you would.
I can do that.
Thank you. So I want to start with, again, applying an Apollo lesson. And these, I should say, just like we're doing yesterday and today, we reviewed these at the beginning of the Constellation program while designing systems that land at the lunar South Pole. Constellation and Artemis have exactly the same landing site and exploration region of interest. One of the Apollo lessons was to develop integrated lunar mission simulations, and there was a variety of programs within the agency that came together and integrated their capabilities to run these simulations through the Desert Rats program, which you've heard about in the past. The simulations that evolved drew on a second Apollo finding, and that is that field-based simulation should engage all those who will be involved in the missions. And you've heard this said in different ways in the last 2 days. Staff were drawn from the Flight Operations Directorate's Astronaut Office and Extravehicular Activity Group, human factors, and the science community. Furthermore, the simulations utilized and developed flight-like hardware, including mobility assets, which were very important, technical adaptations to suits, and a flight control room that integrated flight and science personnel. I want to speak more about that ops situation next. Okay, so just a reminder where we were to where we were going. This is a summary of the Apollo experience. The science operations room was set up outside the FICR, elsewhere in the MCC, and for that reason, it's oftentimes called the science backroom. Astronauts' questions and the SOR's input were relayed back and forth between the FICR and the SOR, and an astronaut could be stationed in the SOR to facilitate that communication. Jim Lovell was commonly that person. Okay, when Constellation began, it was decided to test a new paradigm. That is, science ops consoles were juxtaposed with flight ops consoles in the very same space. There weren't two rooms. And so shown here are two examples. In the top panel is an integrated flight control room and a mobile mission control center that was deployed both at JSC and in Northern Arizona where we did these sims. And then also shown in the bottom panel is an integrated flight control room that we actually built in JSC Building 30 in the Mission Control Center, right across the hallway from the current ISS FICR. I'll just point out, by the way, I'm the Sci lead in this particular sim. I want to point out that Jessica Watkins, who is now one of the Artemis astronauts, was at that time a student and manning one of the science consoles. Okay, so how did this integrated flight control room work? During a simulated mission, a flight director, Capcom, and supporting console staff managed flight operations, including egress from a small pressurized rover. When crews stepped off the vehicle to conduct science station activities or traverse, operations were picked up by a science lead, Sci lead, a science communication, SciComm, and supporting console staff. Operations sequenced back to flight operation personnel at the end of an EVA or if any anomalies occurred. The simulations demonstrated that an integrated flight and science ops architecture greatly enhanced mission productivity and provided crew with lunar surface expertise when engaged in lunar surface activities. Okay, I should also say that the transition from flight operations personnel to science operations personnel also occurred during rover traverses when crew were making IVA observations. This was particularly effective when utilizing the SPR capabilities, which you see listed there. From within the vehicle, I'm sorry, did I hear somebody say something? Okay, from within the vehicle, crew could describe and photo document distant features during drives between stations, as well as in the near field, assisting EVA planning on their approach to each station outcrop prior to egress. The science team developed several products. For example, geologic assessments of the landing sites and pre-mission traverse plans were developed. Mission traverse briefings were developed for the crews. A pre-traverse briefing protocol was developed for crews. Daily pre-traverse briefings for crews were provided. A post-traverse debriefing protocol for crews is developed and implemented through daily post-traverse debriefings. And here you can see a few examples from the 2009 mission simulation. It's important to add that these were fairly high fidelity mission simulations. For example, we used a Generation 1 small pressurized rover, which was tested through a series of 3 14-day and 20-day long mission simulation using crews of 2 and 4 crew. Tests included more than 1,000 hours of astronaut time in the vehicle and nearly 3,000 hours of total crew time in these high fidelity simulations. Tests included daily timelines. Here's 2 examples here. The tools that we use for these timelines evolved as the simulations evolved. And in the final test, we were using the tools used for ISS daily scheduling. I want to skip over this because of the time and move on to training. It became clear in those sims that the scientists working at those consoles need to be trained how to work in a FICRM. I should add that a couple of years ago, FOD very, very kindly gave me some training, the same type of training that they give flight controllers and flight directors. And from that experience, EVA specialists at JSC, Flight Operations Directorate staff, and I developed a 2-week immersive training activity that uses the JSC flight training facility. And we stood that program up last year. We took applications for the program. Unfortunately, we didn't get to implement the first training episode because of the COVID pandemic closed those facilities. But once we do stand that up and run it, participants will be taught spaceflight resource management skills, learn to develop and share situational awareness in a complex mission environment, learn to develop better active listening skills, learn communication protocols, how to package convolute calls, and problem-solving skills relevant to a human mission environment. You heard Jackie and Alex speak about the need for these types of things yesterday. Okay, so in summary, Constellation developed and successfully tested an integrated science and flight operations concept. An integrated science and flight operations room provides crew with lunar expertise during lunar surface ops. The smooth functioning of that team with crew and hardware elements will require field-based mission simulations prior to flight. I would suggest that we avoid the term science backroom for front room science ops because it doesn't really adequately describe a modern integrated science and flight operations architecture. There will, of course, be a backroom support. There is for all of the ISS consoles that will require an additional group of scientists and instrument specialists. Essential to the success of lunar surface science operations are integrated mission simulations, including field-based integrated simulations in places such as the Flagstaff, San Francisco volcanic field. We need to investigate trades among communication protocols, mobility options, surface imaging systems, and sample documentation. And both Apollo and Constellation taught us that science and flight operations staff should work with crew and hardware providers to develop the skills necessary to work as a team during a lunar surface mission. And it's important to say what the benefit of that is. The simulations will uncover unanticipated challenges, produce a well-working team, and give that team the resiliency to successfully resolve unexpected conditions that may arise during a lunar mission simulation, or a lunar surface mission, excuse me. This is something that's very, very important and addressed specifically in flight controller and flight director training. Importantly, for Artemis goals, the constellation simulation should be expanded to include greater variety of in situ resource utilization operations. Artemis simulation should also explore the consequences of rover operations that replace dual SPR with LTV and HMP systems. Thank you very much for your attention.